Dear students, welcome to the knowledge series. We are going to discuss on Bellman-Ford algorithm to find the shortest path. Now here you can see the figure over which we are going to apply the Bellman-Ford algorithms. Now there is a before we start solving this problem, here let me list out some of the steps or the procedures over which this particular problem need to solve. Now the procedures with respect to this Bellman-Ford algorithm is this one. Let me put it this one. Procedure. The procedure number one is that first of all we have to find the list of edges. Okay, those are the things that we have to do, and we have to add we have to designate the vertex, those vertex which is the starting vertex and the rest other vertex, and finally we have to go with the iterations that depend upon number of vertex minus 1. So the very first thing is that to list out the edges from the figure. The next point is that the starting vertex we are assigning the weights as weight is equal to 0 and rest other vertices equal to infinite. Third, we go for applying the relaxation conditions that relaxation conditions applied for number of vertex or number of vertices minus 1. That is the conditions that we follow under these particular procedures. That is, first of all we will list out the edges, and next we will be assigning the vertices with the weight 0 and rest other infinite, and then we go with the relaxation condition number of vertex is equal to number of vertex minus 1. So let's start. So we will start one by one, and before that we have to see here how many what is the direction of the flow and how many vertices are there. So let us assign these vertices in this way. This goes from in these directions, and let us give here also directions and here also directions. Now we will find the vertices. So here number of vertices, how many the number of vertices is equal to 4. So we can put it this one as mod of v is equal to 4. Okay, we can let me put it in a reverse way as mod of v is equal to 4, because we want to put this one as a, when you do a mod we get a positive integers. So number of vertices v minus 1, that is equal to 4 minus 1, that is equal to 3. So that means we can have a number of iterations. Number of iterations 3 is equal to 3 times. So this is the next. Now we will list out the edges and we will proceed. So let me first list out the edges. list of edges. So let us put these edges. We'll put the edges starting with D, B, C, D, A, C, A, B. Let us put the edges randomly. So we are putting like a DB. Sorry, this is for your correction purpose. Let me recorrect this one. So we rewrite this list of edges. We are putting this one as C. Let us start with CD, then BC, then AB, then AD. Let us put this one and let us see how we go further. Now based on this one, we are also keeping the count because number of iteration is equal to 3 we have put. So we are considering count. So based on this count, let us start with 1. So we start with the first count. Now we consider CD. Now if you consider CD, what is the next conditions is that we have to consider all the vertices. So let us create all the vertices. Now this is the starting point. Let us put this one as starting point. So correspondingly this is the end point. So we consider the vertices. So here this is 0 vertices starting, rest are infinite. So based on this one we will be writing CD. So CD, if you try to see, we are having two things. One is infinite weight between C and D. C is having a weight infinite plus of minus 6. That is minus 6 is the link. So automatically this is equal to infinite plus or minus, that is infinite. Between BC, B is infinite and this is 3. So we will write this one infinite plus 3. That is infinite weight of B plus link 3. So automatically it is appeared as infinite weight at C. Then AB. AB, if you try to see, its weight is 0 plus link cost is 2. So that is equal to 2. Now since it has come 2, so we can do the relaxations and modify this one to 2. Now we consider AB. AD. AD is 0 plus 1, that is equal to 1. So automatically we will do the relaxation of this one. So we relax this one to 1. First count is over. Now we go to the next count, 2. When we go to the 2, now we will see CD, CE and D. So what we see, C is infinite plus of minus 6, that is equal to infinite. So at D it is infinite. Infinite is greater than 1, so no change. Now BC, B is how much? 2. 2 plus 3 is 5. So 2 plus 3 is 5. So here it is relax. Here we have to write relax conditions. Okay, and here also relax condition. So here we are having a relax conditions. So automatically this will turn to 5. let me put this one as infinite. So that's what. Now AB, 0 plus 2, 0 plus 2, that is 2, no change. Then AD, 0 plus 1 is 1, no change. Now we go to the third, okay, we got 1, now we go to the third iterations. In the third iterations, C and D. C is how much? 5 plus of minus 6, that is equal to minus 1. So we do a change, relax condition, it becomes minus 1. So this is, we can put it as relax conditions. BC, so 2 plus 3 is 5. So here no change. So 2 plus 3 is 5. So no change. AB, 0 plus 2 is 2. So no change. So 0 plus 2 is 2. So no change. So we got it as same. AB, again we see that one, 0 plus 1, that is equal to 1, which is greater than minus 1. So here no change. So we stop here because of 3 times iterations, that's it. So we got the final weight as here 0, here 2, here 5, and here it is minus 1. So this is how we solve the Bellman-Ford algorithms using a tabular form where we assigns the links, where we assign the link conditions and as well as the weight conditions to solve this numerical problem. Thank you.